start a new metric part file, and then I'm going to go ahead and save this file, and I'm going to call it bearing sorter master. So we're going to do a multi-body solid where we put several parts within a single part file, and we'll push that out to an assembly. So I'm going to start a new sketch on the XY plane, and I will draw a circle, a diameter of 19 millimeters, and I'll draw a second circle 76 millimeters, and then I'm going to draw a line from the origin up to the 12 o'clock position, and I will do a center point rectangle at this 12 o'clock position, and I'll make the width of that 3 millimeters, and I'll make the height equal to the width. So far all of this geometry is fully defined. I am then going to draw a construction line from this point up to the 12 o'clock position on this circle, and I see that it didn't turn dark, so I missed something, probably the vertical. Yes, I missed the vertical. Actually, let's do one more line. So we'll do another line here, and for this line I'm going to make this 2.5 millimeters, and then I'm going to change these three lines to construction. So I'll change this one, and this one to construction. And then I'm going to draw a rectangle, and I'll do this as a 2-point rectangle. And let's do this as a construction rectangle. So I'll do this construction rectangle from here over that, and I want this line in the center to be a center line type, so I'll have it as construction center line, and I'm going to dimension the diametral dimension from here to here as 13.2. I will dimension the height of this as 50 millimeters, and then I'm going to draw another rectangle, and this one I'll do as an object line rectangle, and I'm going to do that from here, and I'll drag this point up to here, and I will dimension the distance from here to here as 1.5. And we're going to revolve this as a tube. Alright, I'm going to now draw a circle on this line, and I want it to come down to this point right here. And then I'm going to trim off 1/2 of this circle, but before I do that, let's go ahead and dimension this. So I'm going to dimension it as a diameter, and let's do this as 12.7. So we see that there's a little bit of clearance between here and here. I'll draw another circle, and be careful you don't get the midpoint of this line. So any place on this line except for the midpoint, and I want it tangent to this circle. Now, it may or may not put that tangent in. It looks like I'll have to add that tangent, and then I will do dimension the diameter of this circle as 13, and I'll draw one more circle. I'm going to do this circle from here, and I want it tangent to this circle, and then I'm going to dimension this circle as 12.4. So I made this one 0.3 less than this one, and then I made this one 0.3 less than this one. So I have 3 different sizes, and I intentionally put those in alternate order rather than do it from smallest to largest or from largest to smallest. I'm going to trim off one side of these arcs. Now, we don't really have to do this step, but I'm going to trim off one side of those arcs. I'm going to change this to an object line. So it will be an object center line, and then we're ready to start making some geometry with these sketches. And so I'm going to say finish sketch, and I'm going to do extrude, and I'm going to select this area minus the keyway. I'm going to go symmetric, and let's do this at distance of 15 millimeters. I want to put a plane up here at the tangent point, and there's several different ways I can do that. I'm going to do it this way. I'll turn on the visibility of that previous sketch, and I'm going to do a plane at this point perpendicular to this line. Alright, let's hide that sketch for a minute, and I'm going to put a hole into this part, and so I'm going to do a new sketch, and I have the origin protected. That's all I want, is that origin, and I'm going to then do a hole feature on this plane at this point, and for the bottom of the hole I want it to be a flat bottom hole, and for the diameter of the hole I want it to be 13.5 millimeters, and for the depth of the hole I also want 13.5 millimeters. We'll say okay to that. Alright, so I have a hole in here. I'll turn off the visibility of this work plane, and I'm going to put a chamfer on here, but I'm going to do this 2 different ways. So I'll do a chamfer on here, and let's do that, say 0.5 millimeters. And so we see that it puts a uniform chamfer going around this edge, but that isn't the way that the tool would really make this in the real world. So I'm going to do it more like it would show up in the the real world. So I'm going to start a new sketch on the plane going through this perpendicular to the XY plane. So I'll go to the XZ plane, I'll do a new sketch, and I'm going to project geometry this arc, and then I'm going to draw a line going over horizontally. In this case, in 3D it's vertical, and I'll go down at an angle and back up. Let's dimension this as 0.5, and I'm going to do equal. I'll make this line equal to this line. It all turns dark, it's all fully constrained. I'll then do revolve, and I'm going to revolve that around the y-axis, and I'll put it on cut. And let's accept this and see if I can determine what the error was on this. I'm not sure why I'm getting an error. So if I expand this where I see the eye, I see that there's an issue indicated with that sketch. So I'm going to edit that sketch, and then I see that this pink point, that indicates that the projection point has been lost. Let's hit F7 for slice graphics so that we can see into our model. And I'm going to delete this curve that we put in here, and I need to delete that line, and it's a projected edge, so I need to delete this constraint on that point. So now this can be dragged anywhere. Rather than project this edge, which turns into a spline, I'll do project geometry, and instead I'll get the edge of the circle, which is this line right here, and then I'll do coincident this point up to here, and it turns dark again. I'll finish sketch, and it's still giving us an error, and I don't know why it doesn't like that sketch. So it shouldn't be giving us that error. So I'm going to delete this line. I'll delete that 6 point, and again, so that's free to move. I think what I'll do is I will just project from the original sketch. So I know that I have a dimension from here to here. Let's change this to a center line. I'll dimension from the center line over to here. That's 13.5, and then I'll turn on the visibility of sketch 1, and I'm going to project geometry this point right here, and then I'll draw a line from here over to that projected point. And if I drag this, I see that this line doesn't stay horizontal, so I'll need to put either a horizontal or a vertical constraint on this. And so I'll do, now it's fully defined, and I can finish sketch. So I don't know why it was giving us an error. It should not have given us that error. I want to go a little bit bigger with my chamfer and the size of the cylinder, so I'll edit that original extrusion, and instead of 15 I'm going to do 20, and on this chamfer I'll edit that sketch, and instead of 0.5 I'm going to do 1.5. We'll accept that, and so that looks pretty good. I'll save this, and then we can do the next body. I want to make 4 copies of this hole going around the disc, so I'm going to do a circular pattern, and I will select the hole feature and this revolution that we use to put the chamfer on, and then I'll do about the center of the disc, and I'll put 4 copies, and we'll say OK to that. So now I have 4 holes going around the part. I'm then going to revolve this, and when I do that, I'm going to do that as a new solid body. So right now we have one solid body, and we might go ahead and name this. I'm going to call this counter disc. Now I'm going to do revolve. I'm going to select inside of this circle, revolve about this axis, and I want to put this on a new solid. And we'll go back and name this. Actually, let's go ahead and name this now. I'm going to call this 12.7 sphere, and then I'll revolve the next one. I'll revolve this area about the axis, and we'll tell it new solid. I'll apply that, and then I'll get this one, revolve this about this axis, and I'll apply that. Let's go ahead and get this, and I'll revolve that about the axis, and we'll say OK to that. Alright, let's rename the rest of these. So I will name this one as 13 sphere. I'll name this one 12.4, and I'll rename this as tube. Let's call it feed tube. I'll turn off the visibility of the sketch, and I'm going to change some colors on some of these components. So on the counter disc, I'm going to set that to be a clear. I'm going to do polycarbonate clear so I can see through that disc. I'm going to do the same thing on the tube, the feed tube. I'll make it polycarbonate clear. Now what I could do is just click with the adjust and pick that up with the eyedropper, pick up that color, and then with the paint bucket drop it onto this component, and I thought I got it on there, but I didn't get it. Let me try that one more time. So we'll do it on the body. So I'll click up this appearance, and I'm going to drop that on the feed tube. There we go. And then I'm going to change the color of each one of these balls, and so I'm going to make the largest one, let's say I'll make that one red, or you can use whatever colors that you want. And then for the smallest one, I'm going to make that one green, and for the middle sized ball, I will make that one yellow. Alright, so I have 3 spheres, 3 different sizes, and 3 different colors. I'll save my master file. I'm then going to go around to the front view, and I'll do a new sketch on the XY plane, and I will do a construction line going over from the origin, and I will then go down vertically, and I'm going to come back at an angle like that, and then I'll come up vertically about like that. I will dimension the angle between these two as 3.5, and then I will dimension the aligned length of this line as 305, and then I'm going to dimension the length of this line as 13.5, and I will dimension the overall length of this line as 340. I'm going to create a work plane through this line perpendicular to the XY plane. So I'll do a plane, I'll select that line, I'll select the XY plane and put it in at 90 degrees. And so I have this plane now. I'll turn off the visibility of this sketch, and actually before I do that, I'm going to project this line. So I'll start a new sketch on this angle plane that I put in, and I'll project geometry, and I'll select this line, and then I'll turn off the visibility of the previous sketch. And I'm going to go to the top view, and I'm going to draw a rectangle, and I want this to be a 3-point rectangle, and I'm going to draw it something about like this, up and about like that. I'm going to change this line to a center line type, and I'm going to dimension the diameter from here to here as 13 millimeters. And when I did that, it shrunk this down, so I'm going to drag this back about like that. And then I'm going to do a circle. I'm trying to decide where I want to put this circle. Let's do a line from here to here, and so I'll do a vertical line from here up to here, and I'll change this to a construction line. And then I'm going to do a dimension from here back to the origin, so I'll do it from here back to the origin, and I will do that as 40 millimeters. And then I'm going to draw a circle on the midpoint of this construction line, and I'm going to do that circle as 12.7. And I'll draw another circle over here, and I'm going to do this circle as 13. And I'm going to do tangent this line to this circle and this line to this circle. So there's a slight angle going down across here. If I try to drag this geometry, we see that circle can move, and so I'm going to do this. Now I did this one at the midpoint of this line, so it can't move. I'm going to put the distance between these circles from here over to here as 76. And then I'm going to draw another circle, and I'll put this circle over here, and I'll do a tangent, and I'll dimension this also is 76 from here to here. Now I can check the radius or the diameter of this. It should be the 12.4. So let's dimension this, and we see that it is the 12.4. I'm going to change these 3 circles to construction, and then I'm going to do a rectangle, and I'll do this as a center point rectangle here, and I'll do another one here, and I'll do another one here, and I will make the width of these rectangles equal, so that's equal to that, and this is equal to that. Also the height, this is equal height to that, and this is equal height to that. I will dimension the width of this rectangle as 25, and I will dimension the height of it. Now the height doesn't really matter, just so long as it goes through this sketch if that was revolved. And so I'm going to do that as 90. we see all of our geometry changes color to indicate that it is fully defined. I'm then going to draw a line from here over to here and a line from here over to here. I'm going to change this line to construction, and I'll change this line to construction, and I'll also change this. So what we have now is we have a zigzag going down, over, up, over, down, and so forth. All right, I'll finish this sketch, and I might have done that on two sketches, this rectangle and these as a separate sketch, but I'll go with what I have, and I'm going to do revolve, and I'm going to revolve this rectangle about this center line, and I'll tell that to create a new solid. I'll turn on the visibility of that sketch, so I'll make that revisible, and I see that there's no thumbtack on here indicating that it's fully constrained, so I want to find where it isn't fully constrained at, and so I'm going to edit that sketch, and I'm going to turn on the degrees of freedom, and I don't see any red arrows on here indicating that anything is free to move, but for some reason Inventor's not seeing it as a fully defined sketch. Now I'll finish that sketch, and I'm going to do a split of this face. So I'll do split, and I'm going to select this is the face that I want to split. I actually need to select the splitting tool first. So I'll select this curve, and so we see that it goes back and forth across here, and then I will do the face I want to split. I'll say okay to that. I'll hide my sketch, and I'll hide the work plane, and then I'm going to temporarily hide this tube. So I'll go to the feed tube, and I'll right click and turn the visibility off on the feed tube, and I'm going to put a color onto this solid body. So I'll go to the properties of that solid body. I'll make that a chrome color, but I want this area and this area and this area to be different colors. So remember that our largest ball will be out here, and I could just turn on the visibility of sketch number 1 to see those dimensions again. So the 13 is the largest. So I want this color out here to be the red. So I'll do adjust. I'll pick up this red color with the eyedropper. I'll click here with the paint bucket to paste that, and then I want the smallest color to be down here, and so I'll do with the adjust, I'll pick up that color, then I'll do it one more time, I'll do adjust, and I'll pick up the yellow color, and I'll drop that at that location. Now you may need to adjust these widths. That is fairly narrow. I think I'll increase that a bit, and so I'm going to edit this sketch. Instead of 25, I'm going to do 30. And I might even increase it beyond that, but I'll go with that for now. And I want to mirror this rod to the other side. Now, in reality, it would be 2 rods, but we're going to treat this 2 rods as a single body. And so let's go ahead and rename this. I'm going to call this sizing rod. And then I'm going to do mirror. I will select the body to mirror, so I'll do mirror solids. I'll select this solid body to mirror, and I'm going to leave it on join, and the mirror plane I'll select as the XY plane, and we'll say okay to that, and so that mirrors that body to the other side. I'll turn off the visibility of my sketches, and I'll turn the visibility of the feed tube back on. I'll save my master file. So we have a master body file with all of our solid bodies within one part file. I want to send those out or push those out to an assembly, so I'll go to the Manage tab, and I'm going to tell it to make components, and I will select these solid bodies, make sure that I have all of them, and then I will put those into bearing sorter, and I'm going to get rid of the master. The master was our multi-body solid, and then for the standard I'll use a metric template, and I'll make sure it's going into your project, and I'll select next, and then I want to use a metric template for each one of these as well. So I'll do a standard millimeter, and I think we can get all of these. I'm not sure. I'm going to hold down the shift key and see if I can get all of those at the same time. Okay, so we see that it's going to use a metric template to create those, and I'll say OK to that. So now I'm in an assembly file. The feed tube and these rods, I'm going to leave those as grounded. So I'll move the feed tube up to the top, and I will move the sizing rods up to the top. So those 2 components will be grounded. I can put an appearance on this. So we lost the clear appearance going from the multi-body solid. I'm not sure if there's a way to avoid that or not. I didn't pay attention when I did the multi-body solid. I think there is a way, but I didn't pay attention to it. I'll do this as polycarbonate clear, and see if I can pick up that appearance and drop it on the counter disc. And so now that one is polycarbonate clear. It might be best if we went into a section view, but before we do that, let's get the other components constrained. So I'm going to unground the counter disc, so now this can move anywhere. Let's turn on the visibility of the origin, and I'm going to attempt to put a joint between the midpoint of this and the origin. I'll expand the origin of the counter disc. I'll have the origin of the assembly visible, and I'm going to do constraint, and I'll do the z-axis of the counter disc to the z-axis of the assembly, and then I'll do flush the XY plane of the assembly to the XY plane of the counter disc. And so now this should revolve. We see that it does, and I'm then going to go into a section view. But first, let's unground these balls, and I think we can just leave those grounded in their position where they're at, so we'll check and see. So I'm going to go to view, and I'll go to half section view, and I'll select the XY plane. Alright, then I'm going to go to dynamic simulation, so I'll go to environment, dynamic simulation, and I need to get the 3 spheres out of the grounded group, and so we need to add a spatial joint to get those out of the grounded group. So I'm going to do insert joint, and I'll do spatial, and I'll select one of these spheres as my first component, and as my second component I'll select this cylinder. And I'm tempted though to select the body that doesn't move, but it shouldn't make any difference, so I'll do apply, and then I'll get the second sphere, and I'll get the second component, apply, and I'll get the third sphere and the second component, and I see that these are still in the grounded group, so we'll right click and unground each one of these. Okay, so now those 3 spheres are in the mobile groups, and then I will do a 3D contact between this sphere and this cylinder. I will do a 3D contact between this sphere and the rods, and remember we did the 2 rods. We're in a section view right now. We did those as one solid body. I'll do a 3D contact between the sphere and this tube, and then we need to repeat the same operations with this ball. So I also need to do a 3D contact between this ball and this ball, and then I need to do a 3D contact between this ball and the tube. I need to do a 3D contact between this ball and the counter disc, and between this ball and the rods, and a 3D contact between this sphere and this sphere, between this sphere and the tube, between this sphere and the cylinder, and between this sphere and the rod. So I think we have all of our 3D contacts on here. Now we may need to make some adjustments on these 3D contacts, but for right now I'll leave those on the default. And then I also want to define gravity, and so I'm going to define gravity, and I'll set it to be perpendicular to this face. I want gravity to go in that direction. I will finish dynamic simulation for a moment, and I'll leave section view. So let's go to view and section, and then we need to drive this cylinder. So let's go back to dynamic simulation. I'll find that revolution joint, and I'll go to properties, 1 degree of freedom, revolution, and I will do the impose motion, enable impose motion. I'll do a constant velocity, let's say of 360 degrees per second. I'll go to my player, and I'm going to increase the number of calculations, and so let's do, let's say 1,000 calculations, and I'll change that time. I'm not sure how long it'll take. Let's take 5 seconds, and we'll save this and then play our simulation. So I'll play. So I'm doing 5,000 calculations. That may be too many. I might try to decrease that. So let's stop this and try to decrease this. And so we'll do 500. Now if we get too few of calculations, we can miss a contact between the balls and one of the other components. I had a lot of trouble with this working correctly if I had all 3 balls in here. I've got it to work in the past, but today for some reason it doesn't work correctly with all 3. But if I do one at a time, the operation that I'm expecting to see then is this ball goes down into the hole and it falls through here. Now because it's up here rather than down here, it's going to miss that first hole, but we'll go ahead and play it. So it didn't quite fall down far enough to get into that first hole, but it will then ride around on the counter disc until it gets to the next hole, and this one it has time to fall into that hole, and then it will continue on around. And so this could be a way of counting the number of balls that you have, and then also a way of sizing them. So when it rolls down, the distance between these two rods gets greater and greater and greater, and so it should fall through that red area. And so you could use this as a inspection device or sizing device for clams, for potatoes, for apples, fruit, whatever you need to count and size.